Welcome everybody. This is the last talk of the first session on Wednesday, the iRODS user group meeting. Chris Jordan's going to talk about all the things iRODS at the Texas Advanced Computing Center. Welcome, Chris.
All right, thank you. So I'm going to talk about kind of a little bit of the history of iRODS at TACC, what we're doing with it now, and then what we see kind of as some of the things we're going to need to work on in the future. So just a little bit about TACC. We're an organized research unit of UT Austin. Now we're kind of known for big NSF HPC systems, Frontera, which is the follow-on to Blue Waters at NCSA, and Stampede 1 and 2, which have been kind of the workhorses of Exceed and academic supercomputing in the United States for the last several years. We have a really diverse array of both resources and user communities, though we have a number of kind of visualization systems, both local and remote. We have a very wide array of data resources, and we serve researchers both at UT, within the UT system, and nationally, and of course, because so many researchers are part of international collaborations. As well these days, we serve users all over the world. The CORRAL storage resource, which is the one I'll talk about most today, is where we run iRODS as a kind of access mechanism, and that resource has supported persistent, what I call high-value research data collections for more than a decade now. And we also have more than 100 petabytes of basically different kinds of scratch storage attached to the HPC clusters, and then another 100 petabytes of tape archive, just to kind of give you a sense of the scope and the scale of the amount of data that we're dealing with from different kinds of communities and of different natures. So a little bit of personal history about why we've been running iRODS at TACC for so long. In the mid-2000s, I worked at the San Diego Supercomputer Center in UC San Diego with Regan and Raja and a whole bunch of people who are probably mostly retired now. I think it was called the DICE group at SDSC. And I was working in more on the systems data management side. And from there, I went to TACC, kind of with the charge being to improve the provisions for research data management at TACC and for the University of Texas. And so iRODS was and is a kind of unique piece of software. There aren't a lot of things out there that do the same thing. So I think if I had been kind of looking competitively across the landscape, I probably still would have ended up on iRODS, but because I was familiar with that group and their work, it was kind of a natural fit for us to use iRODS for some of the first projects that I was working with when I came to TACC. The ARCTOS Natural History collection had a large number of media, mostly images, but other kinds of media, audio and video, and they wanted to manage those and make them web accessible. There was a large collection of archaeological artifacts, mostly again images, but that had very complex metadata associated with them and very highly structured collections. And we were kind of interested in experimenting with ways of integrating archives and disk-based access mechanisms. And we've been running it now for well over a decade at TACC, and obviously, I think we've been through every major version of iRODS, and over that time, the collections we're supporting, the application modes that we're supporting, all of that stuff has evolved pretty significantly, and I'll talk some about that as we go. So CORRAL is the disk system that iRODS primarily services. It was originally commissioned in 2009. It was at that point a 1 petabyte Lustre-based resource. We had a private donation that allowed us to purchase that. support for these kinds of research data focused systems has always been a struggle in the NSF environment. The major kind of advantages of CORRAL for us at TACC, and I would say kind of uniquely among the kind of HPC landscape, was that there was no explicit lifespan on the data that you stored on it. It wasn't like a scratch space or even just a you get only 1 year kind of thing. You could have data there as long as you and we felt that it had value to the research community. And because it was kind of our resource, we could allocate it based on what we thought the research needs and the partnerships that were out there were. So we had a lot more freedom to kind of support research projects than we often would in kinds of scenarios. And we very quickly explicitly tied it to this notion of data services, ways of accessing and managing data, so that the idea of having kind of this persistent high value storage was always associated with having mechanisms to manage, share, and access data. And using iRODS kind of made that a fairly rich conception very early on. So including things like metadata and different access modalities from a very early stage. So we've been able to kind of keep that resource going for the subsequent decade or so. Each time we replace it, we somewhere between triple and double and quadruple the capacity of it. And when we went from the first set of hardware to the second set of hardware, we added this offsite replication, which mostly is done actually at the GPFS level. So we use the GPFS based mechanism to store a second copy of data in the file system in a data center up in Arlington. But then we've also used iRODS for some of that replication as well at times. And then the current system was originally deployed in 2016. The capacity is a little over 12 petabytes. We still have a replica offsite up in Arlington. And at each stage of this, iRODS has been one of the major services that we offer on CORRAL. And because of the nature of iRODS, and I think one of the previous presenters talked about this a little bit, we were able to fairly transparently kind of migrate data from one hardware system to the other underneath the iRODS system, and users didn't necessarily have to be aware of what was happening. So we have three kind of major iRODS deployments now that use CORRAL as the storage backend. We have what I'm calling here kind of a general purpose iRODS deployment. That's basically what you get if you come in through our web user portal and you ask for an allocation on CORRAL and you ask for iRODS. This is what you're going to get. It's an ICAT server and a resource server. And it's available to anybody in the UT system or really anybody in the world if we can work out a partnership with you so that we can support it. We have it integrated with our TACC-wide authentication via the PAM support, and we have this very simple web publication mechanism that I'll talk a bit more about in a minute. And there's about a petabyte of usage in that total, probably about 50 users collectively managing that data in various projects. We support the CYVERSE project through just a resource server. So we're kind of part of the CYVERSE iRODS grid. And we replicate data from the primary site there. And I don't know how much this is being done now. It's something we've kind of talked about continuously since CYVERSE was called iPlant, but we do want that data to be available for local usage since TACC has compute resources that are available to the iPlant community. We want people to be able to retrieve it directly from the TACC resource server if that's where they're doing their computation. And then we have a new iRODS instance that we just deployed in the last couple of months for the Galaxy project. I'll talk a little bit more about that in a minute. At this point, that's in a testing stage. But again, that's using iRODS to mediate access to CORRAL as the backend data store for long-term storage. And we expect to expand the number of resources accessible to that a little bit over time. And that supports computation that's happening both locally and any place that Galaxy has computational resources. So I wanted to talk a little bit about the use cases that we see under the general purpose iRODS. So we also support kind of a simple file system access, the things that anybody would expect with a POSIX file system for CORRAL. So we often end up kind of talking to the user community as they're requesting an allocation and trying to figure out whether their use case matches with iRODS or with a more simple POSIX access modality. So we have kind of a couple of major use cases that I would highlight that have worked best for us with iRODS. One is this, basically large, complex, very long-term collections, stuff that people know they're going to want to keep around for decade-old time scales. They get very large, both in terms of the data size and the number of files, and that may have some kind of specialized needs around metadata, data structure, workflows. One of the things that has come up kind of over and over again in this scenario has been some kind of integration with large-scale instruments that are producing data. So we're not currently doing this anymore, but one of the historical projects that we worked with was the big genome sequencing facility on campus, and we had to set up mechanisms for them to basically dump data directly off of the genome sequencers into the iRODS system, and then use iRODS to distribute data to their researcher community. So a couple of the big ones using the system now is this Mid-American Geospatial Information Center. They basically collect and manage mostly satellite and other geographical data, and then distribute it to researchers, and also, kind of interestingly, first responders. People doing hurricane response often rely on this data because it tells them both what the current state is and what the historical state is for things like flooding after hurricanes. So this is one of those resources that most of the time they're just quietly managing their data, but then every once in a while it becomes very, very important and very in demand. We also have a CT scanning facility on campus, and they a couple of years ago transitioned to using iRODS for managing all of their kind of historical and current data as it comes out of the CT scanner. They're storing it within our iRODS system for eventual long-term archiving. And then this other one, and this was one of the first ones that we started working with, were what I call web-focused collections, collections that really they have kind of long-time archival value, but one of the main purposes that they're using the digital systems for is for distribution of media, usually over the web. And so all of the Arctos natural history collections fall into this category. There are a number of other similar kinds of collections where people are digitizing materials or taking already digitized materials and using iRODS as a publication mechanism, basically, for us. And then we've also been involved in a number of digital preservation and publishing efforts with the Digital Preservation Network, which is now defunct, the Chronopolis project, which is kind of a similar project led out of San Diego, and the Texas Digital Library. All of these are projects that are providing kind of data preservation and publication mechanisms to go alongside traditional scholarly publishing, and those are kind of a natural fit for iRODS. So I just wanted to mention this web access to iRODS collections because it's one of the kind of simplest and dumbest things that I've ever done, but it's turned out to be very successful over the years. And this is you basically, I just create an extra web directory at the top level of our kind of iRODS namespace, and you can give projects a project subdirectory under there and reflect that into a web root. This provides people with a super easy mechanism to basically kind of manage their data in two halves, right? A private half that may be in home directories or a project-specific directory, and then one a web directory where it's explicit that putting data in here is publishing it to the web. And a number of our projects do make use of this. The advantage of it is just pure simplicity, because it's a static web server that's reflecting the data out. It's very simple to manage. It doesn't take a lot of overhead, and it's reasonably easy to keep those kinds of things secure, and it makes for a very quick and easy mechanism for people to do web publication, and people have liked it a lot over the years and made a lot of use of it. So yeah, CYVERSE, I kind of already went over a lot of this. The ICAT is run by the folks in Arizona. We just provide a resource server, and kind of the main issue we've had with that over the years is just making sure that we have the resource server provisioned appropriately to support the quantity of data storage and processing that CYVERSE has, because they do have quite a bit of data that they're managing, and they have some additional processing that they want to do through the rule engine that does happen on the resource server. And I think Tony's going to talk a little bit more about some of what they're doing with the data in iRODS maybe later today. And like I said before, we think that having all of this data locally at TACC and having the resource servers set up does provide opportunities to do more with the data, and to maybe accelerate workflows that are making use of computation resources that happen at TACC. So Galaxy, for those that aren't familiar, Galaxy is an open source web-based platform for data-intensive biomedical research. It's similar to CYVERSE in a lot of ways, but oriented towards the bioinformatics and biomedical communities. And there is already 3.5 petabytes of data stored on CORRAL just using the POSIX interface. And we provide that to dedicated servers that they run the Galaxy software on via NFS mounts. But then just recently, we've kind of started working to test use of an iRODS zone, an ICAT, and a resource server for kind of what I'm thinking of as their static file storage. It's basically the collections of data that are not actively being used in computational workflows, because they have all of this tooling on the back end that pulls the data out either of CORRAL or now of iRODS, and puts it on some local scratch storage, does the computation, and then pulls the data back in. So we've just really gotten started on that, but it's been pretty successful thus far. We have gotten it up and working with the Galaxy code, and once we kind of get that going, there'll be a long-term process of eventually migrating all of the data into the iRODS instance. But then we also think there's a lot more that we can do there with the audit tools, the storage hierarchies, and metadata. And I think we will almost certainly go back to our experimentation with the archive stuff in the future with Galaxy. So I wanted to just mention, having run iRODS now for more than 10 years, and having supported a really wide array of projects, and in many cases just tests with it, I kind of started thinking about the things that we had done with iRODS over the years. And this is not an exhaustive list. And I call it a graveyard, but that doesn't mean that these things were failures. It just means that they were focused on specific communities, or they were only ever meant to demonstrate a particular technology accomplishment, or to help some kind of a project along in its development. but we've done a lot of this over the years. So we've got, I've already mentioned the experimentation with replication to the tape archives. We've done that in a few different scenarios over the years. And we're probably going to go back to that. And so I was very interested to see the work that's been done with Spectrum Archive. I think maybe we'll try and get some of that code. Of course, Dave Fellinger will know that we've done some work with the DDN-WAS technology, which is no longer sold, but at one point we had a demo unit, some hardware at TACC, and we did successfully test integration of iRODS with that demo unit. At one point, I re-implemented the iCommands basically on top of the REST API using Bash and CORRAL, and I promised there was a good reason for me to do that. It wasn't just a let's see if I can thing. We needed audit trails before iRODS had kind of some of the current audit capabilities, and so at one point I had to build basically some additions to the rule engine that would add additional output to the log files to enable us to do the kind of auditing that we needed for one of our projects. We also, I remember, ran the original WebDAV server, which I believe was implemented by a graduate student in Australia and eventually abandoned because he graduated and went on to do other things. And of course, we've run some of the subsequent WebDAV implementations, a couple different variations of the Fuse implementations. I think we had somebody running Fuse mounting the WebDAV server at some point using the Fuse WebDAV stuff. I think I'm almost out of time, but I got one more slide. So I wanted to talk just briefly about kind of what else we think we're going to want to do in the future. The big thing is still interfaces, lots of different interfaces. Users are kind of most interested in simple access to data from where they are, and there isn't a lot of commonality in where they are. That they still run Windows, they run stuff on phones these days, Unix, Macs, web interfaces, all of that stuff, and people want to be able to access and manage their data from whatever seems easiest to them. And so we continue to think that lots of different interfaces to data and finding ways to keep that synced is going to be kind of the most important thing. Compliance is increasingly important. We do have a HIPAA compliant data service, and we would like to be able to do that kind of thing, at least within an iRODS environment. There's lots of requirements around that, most of which are boring and don't necessarily increase security, but they increase kind of traceability. And that's something we're going to pay increasing attention to in future years. Multi-factor authentication is becoming mandatory. We've only done a little bit of work with PAM integration and multi-factor authentication, which we have our own implementation of, but getting that working is going to be important. And then, as I think everybody knows, there's lots of interest in kind of all of these various object store mechanisms. S3 seems to be the most accepted kind of standard for doing interaction with cloud storage. And we see this both in terms of wanting to put data from iRODS into an object store, but also maybe being able to use an S3 interface as a way to get data into our systems, and trying to figure out how to manage all that and provision for it most appropriately is going to be a really interesting challenge. And then finally, everything is kind of becoming more dynamic in terms of how we deploy and manage all of these components, and we would like to continue to do that to basically make managing these things over time and expanding and contracting them to meet need easier. And I think I can wrap up there, and I'll take any questions.
Very good. Thank you, Chris. I know it's a lot to cover. You've got decades of experience, but it's excellent to see it in one place. Thank you so much. John Constable from Sanger would like to know more about the simple web export. He says that sounds very interesting, and he's all for simple things that work well.
Yeah, so yeah, I'm just taking advantage of the fact that iRODS is reflecting at the underlying file system layer, at least in most scenarios, what you're doing at the virtual namespace layer. So if you create a top level directory in the virtual namespace that's called web, you will get a directory in the hierarchy that's called web. And if you set up the file permissions and the web service right, you can have it such that you've got a web server sitting somewhere that's just serving static files out of that directory. And then you can control who has access to that area by either creating a directory for them in the virtual namespace or not creating a directory for them in the virtual namespace. The namespace thing is basically just to make it very clear to people, if you're putting it in here, it's going on the web. And I can share with you how we configure this on our servers with a web server. But if you set things up right, you know what the URL is going to be when you put something in a specific spot in the hierarchy. And so it just creates an easy mechanism for people to get stuff onto the web, and you only have to be involved insofar as you're giving them access to this web area for their project, and then they're responsible for managing it from there.
Got it. I think he's also interested in the Audit Trail homebrew. Is that posted anywhere? Is that public?
It is not, and
yeah.
I would discourage anybody from using it at this point, because that was, the point of that was it was creating facilities that didn't exist then in iRODS. Basically what I was doing was extracting as much information out of the rule engine as I could at every PEP or most of the PEPs. And then dumping them out, I think originally to a file and then eventually to an AMQP server. But I think you can do all of that now more easily using the existing iRODS facilities.
Yeah, it's much more natural now. Edward Munsell from Minnesota. He's interested how the users would get data into and out of iRODS for a cluster job. Do they use iCommands directly in the submit script, or do they typically do something else?
Yeah, I mean, if it's the general purpose kind of iRODS instance, then yes, they use the iCommands, and we have historically had the iCommands available on all of our clusters for that reason. With things like CYVERSE and Galaxy, the data management is done for you. Both of those have their own kind of workflow engines that are managing all of the data movement, so they know where the local scratch is on any given compute resource, and they will pull the data out of iRODS and put it in there as part of the job.
Excellent. Last question, I think. Flavio is in Italy. He says about the Galaxy work, do you plan to run applications directly on the reference data stored in iRODS instead of POSIX? And how do you manage private user data in Galaxy?
Yeah, so Galaxy already has kind of its own notion of what is private and what is public, and they're currently managing a lot of that metadata within their own infrastructure. One of the things we do intend to do with the iRODS integration is eventually push some of that down to the iRODS layer, so that it may not be that iRODS users are owning different data elements, but we may use iRODS to track who the owners of data are, and basically enable Galaxy to do more based on that. But yeah, Galaxy does have its own notion of public collections, and currently it's managing all of that within the POSIX layer. But part of the motivation for going into iRODS is we think iRODS can help with more of that in the future.
And then I lied, there's one more question, came from Jonathan Anderson at UC Boulder. As a relative newcomer to iRODS, I sometimes worry that it might encourage the prototype graveyard more than production use. Can you qualify at all how prevalently iRODS is actually used in production at TACC?
Well, I think it does depend a lot on the project. I would say 90% of our users don't necessarily ever use iRODS, but we do have thousands of users. We have a dedicated base of users that use iRODS all the time and couldn't survive without it. And I would definitely distinguish between things we do because a particular project needs it for a short period of time, or because we're just interested in seeing if a certain technology is going to work, and kind of the day-to-day production operation of iRODS, which is very stable and doesn't really change very much over the course of years. And for those communities of users, which is it's probably a few dozen, it's absolutely essential for them, and they notice and tell me if they can't access it, although it's usually not because iRODS goes down anymore.
Very good. I think that is it. Thank you so much, and this has been a great contribution. I appreciate it.
No problem.